do something fun, in my mind. We'll learn more about how this little magical chip works later when we start to test it, but we're going to add a solid-state relay. Now, in your kit, you will eventually come to what's called a G-switch. And this G-switch, which actually I have it right here. I'm going to go ahead and pull it out. You don't have to do this, unless you want to. Just don't lose it. But this G-switch, we want to have a way to turn on our, and I just pulled all that out and a lot of stuff fell out. So that's the problem with me doing that in advance. And potentially you is you're going to lose or drop maybe, or your cat's going to come in and run off with a stray wire and you'll email us and say you didn't get it. Okay, but anyway, I've got a G-switch, but on our flight we want these devices have to stay powered off while they're on the pad, and but we need to be able to turn them on once the rocket's all sealed up when it launches. And so what we have created is our own little G-switch, and a G-switch stands for gravity switch. And basically what happens is when that rocket takes off, there's enough weight, enough G-forces to push this down and activate our experiment. But when those G-forces are gone, which anywhere between, well, they go off after the first stage, like 5 seconds, it'll pop back off. And then the second stage will kick on and it'll restart it. But then that's off in maybe another 30 seconds, and then it'll come off. And then our experiment would shut off. So the G-switch is a cool way to activate, but we need it to stay on. And that's where this solid-state relay comes in. So this solid-state relay is really a cool little device, and if you look inside the chip itself, it has a little diode inside, a little light-emitting diode, and then inside it has a little light-sensitive switch, so that when we illuminate or power that little internal LED, it is detected and closes the switch. And as long as power remains on that, it will not shut off. So this triggers the solid-state relay, and once it's triggered, it latches and does not turn off. And the circuit is all how that is done. And we'll go through that circuit in a lot more detail than I just went through when we get to the. So with that slide, so I've got all three of these. I've got these LEDs, or LEDs, resistors, this resistor, those resistors. I've got my solid-state relay. I've got my other resistor here and my other capacitor. So I look like I have all that. And we're going to go back to whatever multimeter you're using, which I believe you should all be having these at this point. I'm going to switch it to my musical symbol, which I know, oh my gosh, that's hard to see. I'm going to push my yellow button until I get to the musical speaker symbol right there. And also the ohm symbol in this case. And I'm going to pull this out, and I will make sure that they hopefully still beep. Let's see if I have any continuity between my ears. No, I have 0. But I do have continuity when I touch the probes. Excellent. And the first thing we're going to test on our board here is that we didn't short power to ground. I can test that in multiple places. I can test it right here. I don't hear anything, but I also have 9 volts positive there. And then I have a ground bank up here, so I can test any of these. But if it doesn't beep at power to ground anywhere, hopefully it doesn't beep anywhere. So with that, I would use my check sheet there, and I'll put no beep, and I've passed my first power test. And with that, I can say that my capacitors and resistors are at least working at the moment in terms of not shorting anything. Okay, with that, we're going to take a break. Encourage you to take a break. We'll come back to our Uno, or our Mega, Arduino Mega. We're also going to add in some other components and connection points here. Some of those are headers, some of those are LEDs. So with that, let's start looking at these steps. So again, 44 steps. We're working towards to complete this, and step 20 is right now. So most important connection to make to this board is this one. And the reason for that is all the power for this entire deck that we're building is going to go through these two solder connections. So a lot of pressure here for you to get it right. And probably an area that typically causes students and teams to have the most, I guess, what do you call it, variability in results is they just don't get this one soldered correctly. So we're going to make sure we do a good job. This one is going right here. And as you can see, it's going to go in those two holes, nice and flush to the board, and then when we flip it over, we're going to make sure we have adequate and probably excessive amounts of solder. This thing should not move at all when it's soldered. So right now you can see how that's moving, but we don't want that to happen at all, to have a solid connection. And what we find is when students are having intermittent connectivity, power, or whatever with their board, it's always, when we get to the power test, seems to be around that area. So let's make sure we got a good, clean solder tip, and let's get some solder, and like all other solder connections, heat that pad and fill it in with solder here. So I am bringing, there we go. And I really want that to fill up. So I'm just going to add, oh, got a nice ball there, but if I point the solder down, what I'm going to do is bring to life how this all works. So if we use our and I will use the actual hardware as well. When we connect power to this section, as you see on the schematic, power flows all the way through this board over to pin 3 right here. So when I connect 9 volts, there's going to be 9 volts right there on that pin of my solid state relay, as the schematic says. And when that happens, that's all that happens. But if I short my RBF pins here, I was to short those so that they're touching, connected, you'll see on the schematic that that allows power to flow from here to my G switch, which is an open circuit. But once the G switch is connected and shut due to launch, then that power flows all the way over to pin 1 of my solid state relay in the circuit itself. Only when the G switch is connected and shut. And then inside that magic happens. So inside here from pin 1 to pin 2, a little LED lights up, and inside this it shines the light over here, and there's a detector which then connects this pin right here to this pin. Alright? And when that happens, back to my slides, that causes the power to flow into the circuit to light up this LED right here. And I forgot to mention, oh my gosh, all the way back here, this green LED lights up way back when we go all the way back here. We apply power, we short the RBF, this LED lights up. I forgot to make that known. And then when we get to the point where we've click the G switch, and now we've got power connected from this pin to that pin, this LED will light up, the red one. And then, when we release the G switch, if you see there, I release my G switch, this has remained latched because of the solid state relay, and this LED and the red one will stay lit, no matter what I do with that G switch. So that's how that little system works. And my question to you if we were in person is, well then, how do you actually turn it off? Because if this is latched and I won't want it to go anymore, how would you do that? And the only way you can do that is to remove power here. And once you remove power, then this will no longer have 9 volts on it and the whole thing falls apart, electrically that is. Okay, so hopefully that made sense to you. That's really, again, a fascinating little chip. And how it works and how it keeps something switched on even though the switch has been turned off. So what we're going to do is we're going to actually test this. And we're going to actually apply power to our board for the first time. Now we've tested we don't have any shorts anywhere. And the steps for this test is we're going to verify as we go what I just showed you in the schematic. Do we have 0 volts here? Do we have 9 volts there? Does the LED light up? Does the other LED light up? Does the other LED stay on? All that kind of stuff. So I'm going to take off power. I'm going to leave everything else connected. I'm going to reconnect power. So just as you see here on the slide 46, when I, oops, let me take the jumper off. I'll go ahead and take the G switch off. I'm going to go ahead and reconnect to power. All right. And what I've done is I've verified, or I have connected power to the system, but nothing's turned on. But there is 9 volts right here on pin 3 of my, whatchamacallit, solid state relay. And I can check that right now. All right. There it is, roughly 9 volts. Now, next slide, if I jumper this RBF, as you see in the schematic, I've now got a red light. So truly done that, but nothing has changed with my solid state relay as the schematic shows. I've just armed my system so that the G switch now is active and ready to be triggered. So I will connect my G switch again, and as you can see right here, being mindful that I'm not letting this short something out, I have a G switch ready, has power on it, just as the diagram says. Now when I flip this switch, just as the rocket's launch will do, it's going to send 9 volts up to pin 1, and then that's going to turn on that, and then we'll see that pin get. So I'm going to depress this, the green light will turn on, and by doing that what's happened is it's sent 9 volts here, it's triggered this, now there's 9 volts on pin 4. And when I release it, all that continues to stay in place, and we've just verified it one more time. I will go ahead and test and verify that there is 9 volts right there, and there is. So that's another walkthrough